In this short video, I will be looking at the effect of angle theta on the free body diagram of an object on an inclined plane. Okay, so if we were to draw a free body diagram of this object on an inclined plane, we know that the system of axes that we'll be using now would be that system of axes whereby we have the x-axis and the y-axis. Okay, so same thing applies to this one. The system of axes would be like that, x and the y, and with this one we'd have x and the y. All right, so now let us assume that these objects are sliding down the incline. Okay, and these objects are sliding down the incline on a rough surface. So if it is a rough surface, then it means we have kinetic friction acting between the surface and the object. Okay, so let us see the effect of increasing the angle, right, of inclination. So if I was to draw a free body diagram for the first object, I would have my dot for the free body diagram. Okay, and then I would have FG going downwards, right, gravitational force, and I would have normal force in that direction perpendicular to the surface. Okay, and I would have frictional force in that direction. Okay, so now we see that we will have to resolve FG into two components, and we'll resolve FG into FG perpendicular and FG parallel. Okay, so now we want to see what will happen to this free body diagram if we increase the angle of inclination. Okay, so if we try to increase the angle of inclination, and okay, let me draw this dot for representing the free body diagram. FG would be still acting downwards. Okay, and now we'd have frictional force acting in that direction, right? But one thing that you have to note is that Fk is a function of the normal force, right? So if the normal force changes, the kinetic friction will also change, right? And from this diagram, if you can perform the F net in the y-axis, you can see that the net force is equal to the component of weight, which is the the perpendicular component of weight. So if this perpendicular component of weight changes, the normal force will change and the frictional force will also change. Okay, so how does the component of weight Fg perpendicular change, and how does it change with that Fg parallel? As you increase the angle of inclination, right, Fg perpendicular decreases and Fg parallel increases. Okay, so it means Fg, if we were to resolve weight, right, we would get a smaller Fg perpendicular and now a bigger Fg parallel. Okay, so it means since Fg perpendicular has decreased, then it means the normal force has also decreased. Okay, the normal force has also decreased. And if the normal force has decreased, same thing applies to the friction. The friction has decreased. Okay, so noting the differences between the two free body diagrams is that when you increase the angle of inclination, Fg parallel increases. Okay, FG perpendicular decreases, and when FG perpendicular decreases, the normal force decreases and the friction decreases. Okay, so when you increase the angle of inclination, all the forces decreases in besides FG parallel, okay, because FG parallel increases. So let us further increase the angle of inclination and see what will happen. So if we were to draw a free body diagram for this one now, we'd have FG downwards, right? But if we were to resolve FG, since we have increased the angle of inclination, FG perpendicular will further decrease. Okay, and when FG perpendicular decreases, the normal force also decreases. And when the normal force decreases, even the friction will also decrease, right? But remember, FG parallel will increase. Okay, so those are the changes that we can note when we increase the angle of inclination on the free body diagram. As you increase the angle of inclination, FG parallel increases, but all the other forces decreases, right? And the opposite is true. If you decrease the angle of inclination, right, all the forces will now increase except for FG parallel.